Hello, today we are covering 13.4 inverse trig functions. Notice that I have my unit circle out. So if you don't have your unit circle out, go ahead and press pause and get it out. You are going to need it for today's lesson. So today we are talking about inverse trig. In our last video we talked about find the sine of a certain angle. I could give you degrees or I could give you radians and you had to tell me the sine value. Or you had to find the cosine value. What we're going to do right now is review that. So we want to find the cosine of 5 pi over 6. So that is radians. So we go around our unit circle, we try to find 5 pi over 6, and here it is. Because it's the cosine value, we are looking for the x-coordinate. So when I look at 5 pi over 6, that's 150. The x-coordinate is a negative root 3 over 2. Next one, we want the cosine of 7 pi over 6. We go again looking at our radians. There's 7 pi over 6. Since we went cosine, once again we're looking for the x-coordinate. And once again we see that we have a negative root 3 over 2. Let's move on to some sine values. We want sine of 5 pi over 6. So we look at 5 pi over 6. We want the sine, which means we are looking for the y value. And the y value there is 1/2. And then we want the sine of 7 pi 7 pi over 6. And our sine value there again is our y. This time it is a negative 1/2. How are the cosine values related? Well, we see here that they are the same. Both cosine values are root 3 over 2. Or a negative root 3 over 2. That means that they both have been moved a negative root 3 over 2 left of the origin. Now let's look at how the sine values are related. When we look at the two sine values, they are opposites of each other. So that means that they both are moving 1/2 away, but one moves up and one moves down. So sine is the y value, so positive means that it's moving up and negative means that it's moving down. So let's look at this coming from a different direction. What if I said the cosine of some unknown theta is a negative root 3 over 2? What would theta be? So instead of me telling you, hey, look at this angle, look at this radian measure, and tell me the sine cosine, what if I said, here's the cosine? What theta value gave me that? And I can look, and we know this because we just found it, the angle that's going to give me a cosine of a negative root 3 over 2 is 5 pi over 6, and we know that's 150 degrees. Or I can also get that cosine ratio from looking at 7 pi over 6, which is going to be 210 degrees. What if I was looking for a sine value of 1/2? So I'm looking for a y-coordinate that has 1/2, and we found that that would be 5 pi over 6. And that, again, is your 150 degrees. What else could it be? Now we know it's not going to be 7 pi over 6 because it's a negative 1/2. We're trying to look for what angle measure is going to give us a ratio, a y ratio of 1/2. So if I look all the way around my circle, I'm looking for y coordinates of a positive 1/2. And I see that I have a y coordinate of a positive 1/2 at pi over 6, which is also 30 degrees. If I look anywhere else on my unit circle, no other coordinates are a positive 1/2. And that sine of 1/2 means that I'm moving up 1/2. These are the only 2 points that are moving up a positive 1/2. So inverse trig functions are used to find angle measures. Given the ratio of a trig function. So I could give you sine, cosine, tangent, and you would have to tell me what given angle measure gives that ratio. And you should always, on your unit circle, there's always two possible answers because everything has a partner on the unit circle. However, there's only going to be one correct answer. The measure of the angle could be a number of coterminal angles, but we use the value that corresponds to the unit circle. So we know that 30 is also the same as 390 because 30 plus 360 creates a coterminal angle. We're only going to use the angles found on the unit circle, not coterminals. Also, like I said before, there's always two possibilities. There's only going to be one right answer though, and that one answer, we're only going to use values in one of two quadrants for each of the inverse functions. So if I'm asking for inverse cosine, if I'm looking for theta given a cosine ratio, I'm only looking for the angle measures between 0 and pi or 0 and 180. So I'm looking for the cosine value found in those two places. If I'm looking for theta given a sine value, this one's a little bit tricky. It's going to be between 0 and 90 and 0 and a negative 90. Notice that it does not say positive angle measures here. Anytime it's found down in this portion of your quadrant, you're going to have negative angle measures. So all the way up to negative 90. This could be a negative 30, negative 45, a negative 60. And obviously the same corresponding radian degrees. So if it's in quadrant 1, we are using positive angle measures, but if we are in quadrant 4, we're going to use negative angle measures. I'm not going to say 330 degrees. It has to be stated as a negative 30 degrees. So this is the really tricky one. And actually, the same is going to be true for inverse tangent. So anytime you're given a tangent ratio, it's going to be found in those two quadrants. Same thing is going to be true. When it's located down here, we're going to use the negative angle measures. It could also be found in radians depending on what's being asked for. So just make sure that when you have sine and tangent, it's located in any of these two quadrants. If it's in quadrant 4, you are using negative angle measures, not angles such as 300 or 315 or 330. That's going to become very, very important. So let's go ahead and turn over to the back page. List the angle measures in both degrees and in radians of the given trig value. Hint, use your unit circle. So we want a cosine of root 2 over 2. So I'm just going to try to scroll up just a little bit so you can see from the last page. When we are dealing with cosine, we are only going to take an angle measure from these two quadrants. When I look at my unit circle and I look for a cosine, which is an x value of root 2 over 2, there are going to be two possibilities. X of root 2 over 2 will be found here and here. Both 45 degrees and 315 degrees gives me that cosine value. However, when I'm doing inverse trig for cosine, it's only the angle that's found in quadrant 1 or quadrant 2. This is 1 and 4. Therefore, it has to be your 45 degree angle, which is going to be pi over 4 in radians. Make sure you are labeling degrees and radians in your answers. Now here we can see that's cosine of theta, so I'm solving for that angle measure. We know that these two notations are the exact same thing, saying cosine of theta is equal to that ratio, or theta is equal to the inverse sine of the ratio. So those are two different ways to write just solving for your angle measure. So if I want to find what angle gives me a sine ratio of 1/2, we go to our unit circle. Sine means that we are looking for our y value. What y value is a positive 1/2. It's found right here at 30 degrees and it's found here at 150. But when we reference our chart from above, we know that if I'm looking for inverse sine, if I'm looking for theta from my sine, it has to be from quadrant 1 or quadrant 4. Our choices are 1 and 2, therefore we have to be talking about the 30-degree or pi over 6 angle measure. Next, we have tangent of theta is equal to a negative root 3 over 3. So we look at our unit circle, and we are looking for tangent. Tangent is found in the purple section of our unit circle. Like always, there's going to be two options. We see a tangent of negative root 3 over here, root 3 over 3 over here, and over there. So we have two possibilities, as always, but according to our chart, when we are doing inverse tangent, we are looking at quadrant 1 and 4. My options I found on my unit circle are 2 and 4. Therefore, I must be talking about 330 degrees. But that's not how we're going to say it. Remember, we have to use negative angle measure. So 330 degrees is the same as a negative 30 degrees, which is a negative pi over 6. Very, very, very important that you remember whenever it's in quadrant 4, we are using our negative angle measures. Alright, so now we have 4, 5, and 6. I want you to go ahead and do the next three problems on your own. Make sure that you're giving me your answers in degrees and in radians. Go ahead and press pause. Okay, let's see how you did. Our first one is 150 degrees, 5 pi over 6. If you did not get this, make sure that you check both options, and then we know that cosine has to be in quadrant 1 or 2. So make sure that you pick the correct quadrant. In this case, it's quadrant 2. Tangent, we want what theta is going to give us a tangent value of a negative 1. It has to be quadrant 1 or 4. Therefore, that is 315 degrees, but we need a negative angle measure, so it's a negative 45 degrees and a negative pi over 4. We want sine of a negative root 2 over 2. Again, we have two options, but for sine, it's either 1 or 4. Therefore, it's the same actual angle measure that has a tangent of a negative 1, not 315, but it has to be written as a negative 45 degrees and a negative pi over 4. So we're going to go ahead and do some more work with this, but in our calculator. So this is exact answers from your unit circle. You should also be able to do this in your calculator. So your calculator can help you for other trig functions. Ensure that your calculator is in the right mode depending on what is being asked of you. When an angle measure is not exact, you should have your angle in degrees and minutes for your degree answers. For radians, you should just round to the nearest hundredth or whatever your directions say. So let's go ahead and list the angle measure in both degrees and radians given the trig value. So this time we need our calculator. Let's go ahead and pull that out. Okay, so we want cosine of theta is equal to a negative 0.4531. I checked my mode on my calculator. It's in degrees. So my first answer, we'll go ahead and do degrees. Because we want to find the theta, we want inverse cosine, negative, you can put the 0, don't have to, 0.4531. We hit enter, and then we have to do our DMS. Number 4, and we get 116 degrees, and not 56, but we have to round up to 57 minutes because 33 seconds is going to round that up. Let me go ahead and change our mode into radians, and we're going to do the exact same thing. So you actually can just do second enter twice instead of having to retype everything, but it doesn't matter. And you see here that we get that is going to be 2.04 radians. So when our answers are not exact from the unit circle, we can do both degrees and radians in our calculator. But the most important thing is checking to make sure that your calculator is in the correct mode for the answer that you're looking for. So our next one, we have second tangent because we're looking for the angle measure, 0.9904. We hit enter. Don't forget that that was not degrees. Our calculator is still in radian mode, so that's 0.78 radians. Go ahead and change our calculator back into degree mode. Sometimes it gets a little tedious having to go back and forth between your two modes. Just make sure that you're always double checking. We can just do second enter instead of having to retype it all. And then there's our degrees. We have to change it into degrees, minutes, and seconds. And we end up with 44 degrees. And 25 means it's going to stay the same as 43 minutes. And our next one, we have sine of theta is equal to 4. So second sine 4, enter, and we get an error message. This is actually not possible. We know that sine has to be between 0 and 1. Your cosine and your sine, if you look at your unit circle, no matter what, because we know that any degree bigger than the unit circle or anything smaller is just coterminal, everything has to be between 0 and 1 for your sine and cosine. That is not necessarily true for your tangent. For sine and cosine, your trig functions always have to be between 0 and 1. Okay, we're almost done. We have 2 word problems left to do. Use inverse trig functions and Sohcahtoa to solve for theta. So when I look at this, I want to find my theta. I'm given adjacent, I'm given hypotenuse. That means I have cosine of theta is equal to 15/27. Now this isn't new to you. This is a review. We've done this actually the very first day of the chapter. Since we're solving for our angle measure, we are doing our inverse cosine of that ratio. When we do that inverse cosine, let's go ahead and get out of there, of 15/27. Let's go ahead and start with, we have our degrees, so we put that in degrees. Number 4, remember whenever we have degrees, we always do degrees and minutes, so that's 56 degrees and 15 minutes. We just do our little switch to radians. Go back. Do second enter twice. And we get about 0.98 radians. So you should be comfortable giving degrees and radians. Just pay attention to the directions to see which ones you are being asked for. We have one last problem left. I want you to go ahead and press pause, read through it, and try to solve it on your own. Okay, let's see how you did. First, here's my crane. It has an arm that is 200 feet long. The crane itself is 5 feet off the ground, and it wants to reach the top of the building, which is 130 feet tall. So if that crane is 5 feet off, that means that this portion of my triangle is only 125. That's the opposite side over the hypotenuse, so we want sine of that theta, that angle that we're trying to solve for. We use inverse sine to solve for that angle, and we get 38 degrees 41 minutes, or about 0.68 radians. And that is it for our video today.